For me, I'm a geologist, much more interested in the next little bit. You know, what is iron ore mineralisation? Well, as we said earlier, it's a very common element found in the Earth's crust. When we mine it as iron ore, the main iron ore minerals that we mine are hematite, magnetite, goethite, and limonite. And limonite is in fact a collection of minerals. It's just a family, a loose family that we use to describe a collection of other minerals. But hematite, magnetite, goethite, limonite are the four key iron ore minerals. Occasionally we'll also mine pyrite, which is a sulfide mineral, but we generally only mine pyrite for its iron ore content in a very specific application. So these are the real key minerals that we mine. And you can see there that hematite and magnetite contain 72% iron. So they're really quite pure iron minerals. Most of the world's important sources of iron ore come from sedimentary rocks called banded iron formations, and we'll talk a little bit about that, a bit more about that. But there are other deposits as well which are important sources of iron ore. Related to igneous intrusions, we sort of group them as magmatic type deposits, and we will talk about those as well. You also get some small amounts of iron ore coming from heavy mineral sands, things like beach sands and river sands, where the processes of the beaches and the rivers have concentrated minerals that have been eroded from the landmass, and often the companies mining those products would be mining them primarily for things like ilmenite and rutile and zircons, but magnetite is a fairly common occurrence in those deposits as well. But it really doesn't make up very much production.
Some iron ore is actually found in heavy mineral sands. Will you be able to give us some color on the process of extracting the heavy mineral sands, and also how economically viable is that process?
There are a couple of companies that are processing or mining and processing heavy mineral sands primarily for the iron ore, but most companies are mining the beach sands and the heavy mineral sands for a combination of different things like rutile and ilmenite and zircon and monazite, and there's magnetite often associated with that. And so when the companies are mining those sorts of deposits, they use a range of different processing techniques to separate out the different heavy minerals. And so at the end of the day, what they would like to have is probably different grades of concentrates. So they'll have a zircon concentrate and magnetite concentrate and ilmenite concentrate, things like that. So they can then sell them as separate products to different companies that want those particular products, or upgrade them further. But there's not too many companies around that are doing that, focused primarily on the magnetite, because magnetite it's a relatively cheap mining technique, because the rocks are generally, the deposits are generally unconsolidated, so it's fairly cheap to mine. But then they'll have to upgrade it and send it to the market. And magnetite is, if it was just purely magnetite, is a fairly low value product. Let's talk a little bit about banded iron formations, because banded iron formations are clearly the major source of iron all around the world. They're very distinctive sedimentary rocks. They're almost always very old, and geologically, when we talk about very old, we're talking 600 million years or more. A typical banded iron formation consists of repeated thin layers, sometimes only a few millimetres thick each, of silver black coloured iron oxides, and then an alternating layer which is generally rich in silica, and so you get a very strong banding. And when you get those banded iron formations, they occur in many places around the world. Where you get iron ore accumulations is there's generally been something happen subsequent to those iron ore to the banded iron formations to make them enriched in iron, to allow them to become economically viable to mine. And the three types of deposits that you generally see is what we would call an enriched banded iron formation, where the original iron content has been upgraded through some sort of chemical process to reduce the content of silica generally and increase the content of iron. And so we call that an enrichment, and they're called enriched banded iron formations. We have things called paleo-channel banded iron formations, where the banded iron formation has been eroded and
the material that's been eroded has been washed into river systems and there's been some concentration. And there can be quite rich deposits as well. And detrital banded iron formations where the minerals have been eroded but not in a river system, they've just been eroded by surface gravity systems and been moved downhill and concentrated in that process as well. So they're the three fundamental types of banded iron formations that are enriched enough that warrant them or allow them to be mined economically. Let's think about how we might explore for banded iron formations. Most geologists and most mining companies or exploration companies have a fairly standard process that they go through when they're evaluating or thinking about exploration. And this is a generic slide which would cover virtually all commodities, and banded iron would be no different. You first of all think about what's my exploration model or what's my concept, what do I want to go and find, where am I going to go and look for it. You'll do some background work in that and ultimately you might choose an area, you'll go and obtain title from the government to grant you access to exploration. You'll do some reconnaissance or regional type work to assess that ground. You might generate some targets that you want to test and you will initially do some testing, generally by drilling, some form of drilling to test those. At that point you might choose to walk away because you haven't really found anything of interest, but if you find something of interest then you generally locate something, you'll then drill it out further testing, and you go through iterative stages where at the end of those stages, if you've been successful, you'll produce a mineral resource estimate, an ore reserve estimate, and get funding for development and actually start a mine. So it's a fairly generic process that applies to all commodities. When it comes to banded iron formations, generally speaking, economically attractive banded iron formations are typically found quite close to the Earth's surface. They're very, very large deposits, cover many kilometres, and they can contain extremely large tonnages of iron ore, up to billions of tonnes in an individual deposit. So they can be very, very large deposits. They can be anything from 5 to 200 metres thick as well. So as a consequence of that, the exploration for them is, I'm going to say, relatively simple because they're things that you expect to find close to the Earth's surface, or in many parts of the world they're right on the Earth's surface and are very clearly visible. So you might use satellite imagery and analyse the information you get from that. You might use aircraft with sensing technology on them. You'll then go down to the surface and do some work on the surface. And ultimately you might do some drilling at the end of the day to actually prove those up. And you can see there's an example in the picture there of a drill rig in Western Australia in this instance, and you can see how flat the country is there. Virtually no vegetation, and that deposit is pretty well exposed at surface. So it's relatively simple type of exploration process. When you find something in a banded iron formation, it's generally inevitably a very large scale operation. And that generally means that you're limited to the certain types of companies that have the resources to actually exploit something like that. Very large operations, a lot of capital to get them up and running, but they produce a lot of material as well. And in the case of a lot of operations, they need close access to very large port facilities for export. And typically in the case of Brazil and Australia and India, where you're doing a lot of export, sometimes it's even more important than actually having a deposit is to have access, either rail access or road access, to a port relatively close by so you can keep your costs down. And so we're talking very large operations and generally controlled by very large companies. So the other source of banded iron formations comes from what we'll loosely call magmatic iron ore deposits. And generally these are much smaller than banded iron formations, and they're more geologically complicated because unfortunately that's just the way they're formed. They can cover quite small areas, but some of them actually can be quite large areas as well. And you can see there that some of them are quite small, 5 to 100 metres thick, but occasionally you'll find a deposit that is hundreds or thousands of metres thick, but it's still really only covering quite a small aerial extent, but it's a very thick thick deposit. So consequently, exploration generally follows the same process. You're using satellite imagery or airborne imagery, you're using surface geochemical techniques or surface geophysical techniques and ultimately drilling. But they're a lot more difficult to find unless they're at the Earth's surface. And a lot of these deposits are not at the Earth's surface, so you actually have to do a fair bit of investigation to find them. Some of the mining of magmatic ore deposits, generally speaking, are a lot smaller. And there's some examples here where you can see here. Here's a zone of iron that's being mined here, and in this instance it's almost vertical. So it just doesn't have the same extent that a banded iron formation has. It's much smaller, but the upside of that is smaller companies have the resources to exploit these deposits.
You mentioned under iron ore mineralization that some iron ore deposits are linked to igneous intrusions. Now, what is an igneous intrusion?
Well, igneous intrusions are basically, as I was talking about in terms of the magmatic sulfur deposits, igneous intrusions are where you'll have areas of the Earth where for some reason or another there's quite a lot of heat, and the actual country rock and the rock is actually being melted. It's so hot that the rocks melt and they form liquids. And these liquids, which are 1500 degrees Celsius or more even, these liquids then just migrate, generally move upwards in the Earth's crust, and we call these igneous intrusions because they're intruding through the country rock that isn't melted, and they generally move up, reach a point in the Earth's crust where it starts getting cooler, they start to solidify and turn into or recrystallise into what we call igneous intrusions or igneous intrusive rocks.